Good morning, this is Mr. Sala. I had a couple of emails about how to use Kepler's third law to solve for numbers 5, 6, and 7 in the problem set. So here is Kepler's third law. You have the period of one object over the period of another object, and those would be squared. And then you'd have the radius of object A over the radius of object B, and those are cubed. So that's the equation for the third law. So the only planet that you see here that has both pieces of data is Earth. So you're certainly going to use that to start. So we're going to look at 5. So we're missing the distance or the radius here, and we have the period for Mercury. So again, we can call Earth A and then Mercury B, and then we can plug in what we know. So we know that the period for Earth is going to be 365.2, and that's going to be squared. And we also know the period for B, which is Mercury. So that would be 88 squared. Right? Now we know the radius for Earth, so that's 1.5 times 10, and that's actually to the 11th because this is the 8th for kilometers, but you want to be in meters, so you would change that to 11, and then that would be cubed. And then what you don't know is you don't know the radius for B. Right, so then what you need to do is just rework that equation. And again, that is cubed. So when you rework the equation, you have R of B cubed, right, because you cross multiply and then isolate, right? So then you would have 88 squared 1.50 times 10 to the 11th 10 to the 11th cubed, right? And then that would be all over your 365.2 squared. And remember, you're going to have to take the cube root of each side to ultimately isolate for the radius of Mercury. So I'll let you solve that problem. Then what you'll wind up having is you'll have two pieces or two planets where you have both sets of data, and then you can use either of those to then solve for 6 and 7. Hope this helps. Any other questions, please email me. Have a good weekend.